Now let us talk about alkenes. Alkenes are hydrocarbons that contain a carbon-carbon double bond. The number of hydrogen atoms in an alkene is double the number of carbon atoms. For example, the molecular formula of ethene is C2H4, while for propene it is C3H6. The structure of alkene molecules. Carbon-carbon double bond in alkenes consists of one strong sigma bond with bond enthalpy about 397 kJ per mol due to head-on overlapping of sp2 hybridized orbitals, and one weak pi bond with bond enthalpy about 284 kJ per mol obtained by lateral or sideways overlapping of the two 2p orbitals of the two carbon atoms. The double bond is shorter, in bond length 134 picometer, than the carbon-carbon single bond, which is 154 picometer. You have already read that the pi bond is a weaker bond, due to poor sideways overlapping between the two 2p orbitals. Thus, the presence of the pi bond makes alkenes behave as sources of loosely held mobile electrons. Therefore, alkenes are easily attacked by reagents or compounds which are in search of electrons. Such reagents are called electrophilic reagents. The presence of weaker pi bond makes alkenes unstable molecules in comparison to alkanes, and thus, alkenes can be changed into single bond compounds by combining with the electrophilic reagents. Strength of the double bond, which has a bond enthalpy 681 kJ per mol, is greater than that of a carbon-carbon single bond in Fe, which has a bond enthalpy of 348 kJ per mol. We will talk about the physical properties of alkene molecules in this section. Alkenes as a class resemble alkanes in physical properties, except in types of isomerism and difference in polar nature. The first three members are gases, the next 14 are liquids, and the higher ones are solids. Ethene is a colorless gas with a faint sweet smell. All other alkenes are colorless and odorless, insoluble in water, but fairly soluble in non-polar solvents like benzene, petroleum ether. They show a regular increase in boiling point, with increase in size. That is, every CH2 group added increases boiling point by 20-30 Kelvin. Like alkanes, straight-chain alkenes have higher boiling point than isomeric branched chain compounds. Now let us talk about the chemical properties of alkenes. Alkenes are the rich source of loosely held pi electrons, due to which they show addition reactions in which the electrophiles add on to the carbon-carbon double bond to form the addition products. Some reagents also add by free radical mechanism. There are cases when, under special conditions, alkenes also undergo free radical substitution reactions. Oxidase and azolysis reactions are also quite prominent in alkenes.